Good day, everyone. Welcome back. We're going to be going over topic 5.2 from the polynomials unit in Math 10C. This topic or lesson is called the greatest common factor. And in this, which can be found on page 10 of your unit handout, we're going to be looking at what's called factoring. And without getting into too much detail, factoring is the opposite of what we've been doing so far. And you'll learn about that in detail in a few minutes. One method of factoring is to use what's called a greatest common factor. So we're going to start by figuring out what a greatest common factor is, progress to using a greatest common factor to factor a polynomial, and then we're also going to be looking at factoring by grouping. To begin with here, factors of any mathematical expression are things that multiply to give that expression. I'm going to come back to this a couple of times probably throughout this lesson. But basically what this is saying is things that multiply to give an item are factors of the item. So for example, in the warm-up, it says write each expression as a product of factors. Well, I can certainly write 68 as 1 times 68. It's not a very imaginative solution to this question, but I could do that. And that means that if I were to make a list of factors of 68, then in my list would be the number 1 and the number 68. With a little more effort, I can say, well, 68 is an even number because it ends in an even digit, which means it's divisible by 2. And I can calculate either with my brain or my calculator that 2 times 34 is 68. I just took 68 divided by 2, it gives me 34. Which means that 2 is also a factor of 68, and 34 is also a factor of 68. With a little more effort, I can see that I could also write 4 times 17. And the purpose of this lesson is not for us to find these factors for numbers. We're using this first part of the warm-up to build up to something else that is more algebraic in nature. So because 4 times 17 is 68, I could also write that 4 is a factor of 68, and so is 17 a factor of 68. The best way for you to write out what 68 is in factored form is to take it right to the end, like we did when we were working with radicals. If 68 is 4 times 17, I know that 4 is 2 times 2, which means 68 is 2 times 2 times 17. And this is what we would probably call the prime factorization. Briefly, I want you to notice that every single item in our list of factors of 68 are included in the prime factorization. You know, is 34 included in there? So my list of factors are on the right-hand side of this line, and the prime factorization is at the bottom of the left. Is 64, which is a factor, is 34, which is a factor of 68, is it included in this prime factorization? Well, sure. 34 is included in there because 34 is 2 times 17. Every single factor of 68 is included in that prime factorization. Let's take a look at number 2, 4x squared y cubed. So what are we asked to do? We're asked to write it as a product of factors. I mean, could you write 1 times 4x squared y cubed? Yes, but I think you understand that's not the intention. We want to tear this down as much as possible. 4 is 2 times 2. X squared is x times x. And y cubed is y times y times y. Done. And every single factor of 4x squared y cubed is in there somewhere. If you pick any of those items and multiply them together, and for goodness sake, I'm not going to do many of these, I'll just do one. If you pick this 2 and this x and this y and multiply them together, you would get 2x squared y. And 2x squared y then is a factor of 4x squared y cubed. It's one of many factors, but we're not going to list the factors. We're simply doing the prime factorization. Over here, the best we can do is write that 3 in brackets, the a in brackets, and then the a minus 2b in brackets. The factors, I am going to list them here, are 3a and a minus 2b. This a minus 2b is in its own set of brackets and cannot be written as a product of different things other than one. So that's it. That's our answer. Now we're going to look at the greatest common factor. So we're going to start off with numbers here. And I've already pulled up and typed in all of the factors of 72. So you can take a second and scan that list, but basically every number in that list can be multiplied by something else to give 72. For example, 4 is in that list. It turns out that 4 can be multiplied by 18 to give 72. By the way, that makes 18 a factor. Why is 36 in the list? Because 36 times 2 gives you 72. Why is 3 in the list? Well, because 3 times 24 gives you 72. So you'll have to just trust me on that. Those are all of the factors of 72. And these are all of the factors of 48. So what is the greatest common factor? Well, we start off by saying, what are the common factors? 1 is a common factor. 2 is a common factor. 3 is a common factor. 4 is a common factor. 6 is a common factor. 8 is a common factor. All of these numbers are divisible without remainder into both 72 and 48. 12 is a common factor. 9 is not. 12 divides into both of them without remainder. 24 does. And we have hit the end of the line, which means the greatest common factor is 24. And all I'm doing here is convincing you by giving you the list of numbers that 24 is the greatest common factor. Now, how would you find the greatest common factor without making that list? The answer is you would take 72 and 48 and you would put them into prime factorization. So 72 is 2 times 36. I know many of you like to whittle things away by dividing by 2 and dividing by 2. I'm going to get there a little bit quicker by saying 36 is 6 times 6. The first 6 is 2 times 3. The second 6 is 2 times 3. And you can confirm right now if you like. The 2 times 2 times 3 times 2 times 3 will give you 72. 48, I'm going to write it as 4 times 12. 4 is 2 times 2. 12 is 4 times 3. And that 4 I can break down into 2 more 2's. So 2 times the 4, which is 2 times 2 times 3. And what we are going to do, well, you can check right now if 2 times 2 times 2 times 2 times 3 is 48. And what we are going to do is find all of the common factors. For example, there is a 2 here and here. There's another 2 here and here. There's another 2 here and here. So each of these numbers, 48 and 72, have 2 times 2 times 2 as a factor. There is also a common factor of 3 here and here. Just make note here that this 3 does not have a common partner of 3 on the other one, And this 2 doesn't have a common partner of 2 on the other one. So what do these things have in common? They have in common the blue highlighted stuff. And if you take 2, the highlighted stuff, you take 2 times 2 times 3 times 2. In no particular order. There's 3 2's and a 3. You get 24. So that's what the concept of a greatest common factor is about. How can we use that here? Well, if I write 12x cubed y squared, 12 is 2 times 2 times 3. X cubed is x times x times y times y. Because it's y squared. What do I have here for the 9? I have 3 times 3. For the x squared, I have x times x, and I have a single y. So there is some common factoring going on here in terms of the numbers. There's a 3 and a 3, which means that my greatest common factor has to have a 3. What else do we have? I've got some x's. I've got an x here and an x here that's common, and a second x and a second x that's common. No more x's that are common, which means my common factor is x squared, or the contribution of the x's to the greatest common factor is x squared. And then I also have a y in each, so I have to include a y in the greatest common factor. Now, in order to kind of streamline this a bit, you can notice that when you look at the x's in each of the 2 terms, when you take a look at the x cubed and the x squared, and you look at the greatest common factor has x squared. The greatest common factor will have the variable raised to the lowest exponent that you see in the terms. If I take a look at the y's, this is y squared and this is y to the 1. So the lowest exponent is 1, which means the greatest common factor is 1. And most of the time, students are very adept, which means they're good at identifying the greatest common factor of the coefficients. So the greatest common factor of 9 and 12 is 3, and then it's x squared y. Number 3, what is the greatest common factor? Well, the first expression can be written as 3 times 2 times b. And then again, this binomial is a factor by itself. The second expression is 5 times b times 2a minus b. So what is the greatest common factor? We've got a b in each, and we have a 2a minus b in each. So the GCF is b times 2a minus b. All right, so now let's talk about what factoring is in general. When an expression is factored, it is written as a product of its factors. Well, that kind of makes sense. For example, the expression 5x minus 10, if I factor it, becomes 5 multiplied by x minus 2. And just take a second here and ask yourself what would happen if you multiplied 5 by x minus 2 in brackets. You'd get 5x minus 10 because of the distributive property. So the expression on the left at the bottom of the screen is the factored form, and the expression on the right is what we can call the expanded form. To go from factored form to expanded form, you multiply. To go from the expanded back is called factoring. So it turns out we have been factoring some of these expressions, but they're going to get just a little bit more complicated starting now. Factor the following by finding the GCF. So what is the greatest common factor of 4x and 12? Well, it's 4. And, you know, this bit about writing 4x as 2 times x, and 12 as 2 times 2 times 3, and then saying, oh, well, there's a 2 here and here, and there's a 2 here and here. 2 times 2 is 4. That whole bit of business is there to get you to understand what's going on. I would expect everybody to know that the greatest common factor between 4x and 12 is 4. So what does this mean in terms of factoring? It means that you can write 4x minus 12 as 4 multiplied by something, because 4 is a factor. Now, what would we multiply 4 by to get 4x? So this is my thinking here. I want to do some highlighting to get you to follow along with my thinking. What would we put here in the yellow highlight so that when we multiplied it by the 4, we'd get 4x? And the answer is x. You'd have to put an x here. Minus, what would we put in the green to get this one? So when we multiply, let me write out one more thing here. When we multiply this through, that gives us the 4x. I'm saying, what do we put here so that we will get a 12? And it's 3. So in factored form, it's 4 times x minus 3. And you can notice that this x that's highlighted in yellow is written there because up here, where I have 2 times x wasn't highlighted. We need to include it. Same thing goes for the 3. So this is our answer. What about this? Well, again, if you have to, let me write out what the GCF is first. The GCF will contain the greatest common factor of 1 and 3, which is just 1. And it will contain the greatest common factor of r squared and r to the 1. But the shortcut is to say it's going to contain r to the smallest exponent, which should be r to the 1. If you want to write this out, here is the prime factorization of 3r squared. Here is the factorization of 1r. What's common? Well, what's common is there's an r in each. And that's why the greatest common factor is r. What does that mean? It means that we can write 3r squared plus 1r to the 1 as r multiplied by something. Well, what do we put here so that when we multiply this through, we get 3r squared? Well, I need a 3 and an r. Plus, because there's a plus here, what do I put here so that when I multiply by r, I get r? And the answer is 1. So r times 3r plus 1 is the answer. And I would ask you right now, if you need to pause the video for a little bit extra time, that's fine. I would ask you right now to multiply out 4 times x minus 3 and multiply out r times 3r plus 1 and confirm that you will get 4x minus 12 and 3r squared minus r. Pardon me, 3r squared plus r. And you will. Try another one. So what do these coefficients have in common? Don't freak out when you look at this. This is simple when you break it down. The greatest common factor will contain the greatest common factor of the coefficients. So what is the greatest common factor of 2, 4, and 8? The answer is 2. It's the biggest number that divides into all of those. What is the greatest common factor of the a's? Well, I have a squared, and I have a squared, and I have a squared. Well, I can factor out a squared. It's common to both. Is b a common factor? No, because there's only b in the first term. C is not common because there's not c in everything, and neither is d. What that means is that we can write this as 2a squared multiplied by something. And because we're factoring 2a squared out of 1, 2, 3 terms, we're going to have 1, 2, 3 terms. What we put here has to multiply by 2a squared to give this. Well, it's b. Don't just blindly write stuff down. Pause the video if you need to. Look at what you're writing down. Think about it. What do we put here? What we put here is something that multiplies by 2a squared to give 4a squared c. Well, I need a 2. Otherwise, I won't get the 4, and I need a c. Whatever we put in the last slot has to multiply by 2a squared to give 8a squared d. So we need a 4 to turn the 2 into an 8. We don't need any a squareds. They're going to show up when we multiply, and we need a d. So the answer to this is 2a squared and then times b plus 2c minus 4d. And again, if you like, pause the video and multiply this out and confirm that you're going to get what is at the top of the screen. (12x squared y minus 8x squared y squared minus 9xy). Okay, so the greatest common factor will contain the greatest common factor of 12, 8, and 9. And there isn't one. Well, there's one. If I look at 12, which is 2 times 2 times 3, and I look at 8, which is 2 times 2 times 2, and I look at 9, which is 3 times 3, there is no single number that appears in all three of those things. So I can't factor out any number. However, I can factor out x to the 1 and y to the 1. The shortcut without factoring all of these individual terms is they all contain x, and the lowest exponent on x is x to the 1. They all contain y, the lowest exponent on y is 1. That's the GCF, which means it can be written as xy times some stuff. You have to figure out what to write here, and then it's minus, here, then it's minus, and here, so that if you multiply this through, you will get the thing that we started off with. Well, I need a 12, and I need an x, and that's it. I need an x because I got to get x squared. Over here, I need an 8. I need an x and a y. That will give me x squared, y squared. And over here, I just need a 9. So it's xy times 12x minus 8xy minus 9. And again, feel free to multiply that out and confirm to yourself that it will give you what we started off with. Now, this polynomial has two terms. This is a term, this is one term, and this is one term. What do they have in common? Well, let me write this out. This one has a 2 and a c and a 3c minus d. This one has a 5 and a d and a 3c minus d. Well, they both have a 3c minus d. So we factor the 3c minus d out because it's the greatest common factor. What do we have left? Well, 2c minus 5d. And the final one in this section, you can factor out an x minus 6 out of both of these and be left with 5x out of the first minus 4 out of the second. And what you may have noticed, hopefully if I've done my job well, you haven't really noticed, is that we've gone from having to do a lot of work with these to doing less and less. By the way, the greatest common factor here is x minus 6. All right, there's one more thing I want to look at in this video. It's factoring by grouping. And I want to give you a bit of background why we're doing this. One method of factoring that we will look at a little bit later in the unit requires that you know how to do factoring by grouping. By the time you get into grade 11, factoring by grouping is going to be something that you rarely use. So here's the process to factor by grouping. The first thing is, when you have the 4 terms, you group them into 2 pairs. In other words, you create 2 binomials. And this plus in between them is crucial. And then what you do is you factor each pair using a greatest common factor. For example, in this pair, you have a greatest common factor of 3x. In this pair, you have a greatest common factor of 2. So if we factor the 3x out of this, we are going to be left with x minus 4, because 3x times x would give you 3x squared. 3x times negative 4 would give you negative 12x. If we factor the 2 out of the second pair, we're left with, surprise, surprise, x minus 4. And the fact that you're left with the same thing here out of the first pair as you are out of the second pair means factoring by grouping works. It won't always work. And now what we do is we look at this as being one large term plus one large term. And we say to ourselves that there's an x minus 4 in each, so I can factor that out. And what do I have left out of this first term here? I have 3x. And what do I have left out of the second big term here? I have 2. And that's the answer. Let's take a look at this one. 3p to the 4 plus 2p cubed in its own set of brackets. Remember, I said you need a plus here. So in the second set of brackets, negative 6p minus 4. The greatest common factor here is p cubed. The greatest common factor here is is 2, but I'm going to put negative 2, and you'll see why in a second. So I factor out p cubed, and I'm left with 3p plus 2. The reason why I want to factor out negative 2 is because then I will be left with positive 3p plus 2, and this matches with that. Which means I can factor the 3p plus 2 out and be left with p cubed minus 2. Let's try a couple more. Group them into 2 pairs. Make sure you have plus in between, which means that minus 15, that negative goes with the 15s. I can factor an r out of this and be left with 3s minus 2. I want to pause for a second here. This is what I was just talking about. The purpose is to factor. I don't need to write greatest common factor as r. I can see there's an r in each, so I factor them out. Now the question becomes, what should I factor out of this so that I'm left with 3s minus 2? I want to be left with the same thing here and here. Well, in order to make the negative 15s positive, I'm going to have to factor out a negative, and a 5 would do the trick. Now I can factor the 3s minus 2 out of each of these big terms and be left with r minus 5. There is one more in your handout, but I do not want to do it with you because it involves a twist that I don't feel is worth the time or the effort. So you're looking here at factoring using a greatest common factor and learning how to factor by grouping. I had mentioned to you early on in the unit that this is the unit where, as my dad would say, the rubber meets the road, which means we're going to have to really, really work hard here, some of us. This is not going to come easy necessarily. So you're going to have to sit down, and like I said in the previous lesson, it's not something that you can do 5 minutes of and then take a break and do 5 minutes of. You need to sit down for a half hour at a time and work on math. So if you need to watch the video a second time, that's fine, but you got to keep up with things. I hope that made sense, and I hope you do well with it. Looking forward to seeing you soon. Take care.